So the two common themes that I've noticed in CoPAP's culture is their empathy towards their students and also their commitment to empowering students. And as a tech fellow, I knew it was my commitment and also my responsibility to emphasize these two cultures carry these themes through the students in my breakout rooms. So, for example, when I join a student breakout room, I like to assess students' energy levels, and what I mean by that, I meant their engagement, and also to see if the students are awake or they're just completely tired. And if I see a student who's tired and drowsy, I like to make an opening statement. I like to say, "Hey, I understand everyone's tired. I'm from the East Coast, New York City, so I understand your pain. But just be proud that you still showed up despite feeling tired." So this statement alone, I'm acknowledging my students. I'm acknowledging their commitment and also their pain, but also being personal and relatable. And from that comment alone, I've noticed that it really brightens the mood. It keeps students awake and engaged because these people are half awake and they're smiling. And from there, I like to start conversations and piggyback from people smiling. That way, everyone's engaged and awake. So when it keeps to empowering, right? When I leave a breakout room, I don't like leaving unannounced. I like to leave a breakout room on a more positive note, especially late at night. So I will say, "Hey, you guys are doing well. Hopefully we run into each other as colleagues at Google in the near future." And this comment, it makes a lot of laughs and giggles, and I believe that's my way of, having a positive impact on these students because, in their shoes, it's late at night. The last thing they want to feel is feeling bummed out from not being able to solve a code or figure out a problem with a classmate. So this is my way of carrying CoPAV's culture by empowering students by making, jokes about working together in the future at Google, or maybe, I don't know. I like to say Google's too old school, maybe SpaceX or open AI. These are the jokes I like to make, so that way it keeps students encouraged and also motivated, and also, bring up my own personal dialogue with me saying, "Oh, I'm from New York City." That's my way of being empathetic towards them because I'm not just a tech fellow, I'm also a student who's also sharing late nights with you. So that'll be all. Thank you. Hello, my name is Brian Gonzalez, and tonight I will be your tech fellow. So I've noticed that you're having some trouble understanding binary search, and that's totally okay. And honestly, if it takes me more than an hour to understand or try to figure out a problem, I'll simply use ChatGPT to help me. So let me walk you through how to use ChatGPT so that way ChatGPT doesn't give you the answers directly. So the exercise I like to do is by asking students and their peers on providing their own definition of what binary search is. So feel free to take your time on coming up with your own definition and paste it in chat. Alright, so congrats on writing your own intuition definition of what binary search is. That's one step closer to understanding and also problem solving, right? So the way I want to prompt GPT is by saying, "Hey, check my understanding and explain what I got right and wrong within 1 to 2 sentences." So let me paste that right after we provided our own definition. And I do want to point out, right, I'm just going to walk you through the understanding and planning phase, but for the remaining time we have, you and your group mates should be able to implement this in pure Python code. And I also do want to point out that as you're using ChatGPT and asking for more information, right, feel free to write notes down, and that way you can be able to pick out any flaws or any misunderstandings that you have, and that way you can, refine your questions and ask GPT another follow-up question. So another follow-up question could be like, well, how do I know which side to look at, left or right? So let's say that was your hypothetical question. I would then say to GPT right after my question would be, "Do not give me the code and explain within 1 to 2 sentences." We're explicitly telling GPT not to give us a direct answer, but while also restraining GPT from giving us too much information. Let's feed our second prompt into GPT and see what GPT spits out. So as you're taking your time reading this, I also recommend that if you have a third follow-up question, copy and paste that same exact prompt that we mentioned prior. That way GPT doesn't give us the code directly. So let's transition from our understanding phase towards our planning phase. So we can safely agree that this is a two-pointer method that requires us to check the left and right side of our array. So we can declare our right and left pointers to be beginning and end of our array, or in other words, we're pointing to the beginning and left of our array. And keep in mind that we're repeatedly shrinking our array until we reach the middle. So this requires us to use a while loop. So we can say while our left pointer is less than or equal to our right pointer, we can continue our loop. So continue loop. And if you don't understand why, I like to provide a visual on how this works. So imagine our left pointer and our right pointer is slowly creeping towards the middle, checking each value. If the moment we intersect each other or interlap, if that's a word, right, we return -1 because within our while loop, right, we write a condition that spots a target value within left and right. But if they overlap, that means that our target value does not exist. So we can return -1 in our outer loop. So let's go inside our while loop and write some conditions. Let's say if our middle value or middle item is our target, then we return the middle position. Return middle position. But what if our target is less than the middle item? So we can say if target less than our middle item, we can search only the left side and update our right bound by middle -1. Search middle item, search left side, and then we can say update right bound by middle -1, and vice versa. We can say if target is greater than our middle item, we can search our right side. So search right side, and then we can update our left bound by middle +1. We do this continuously until they intersect or they return a value, which exits the loop. So hopefully this helps clarify a few things, and I wish you students best of luck.